Hello everyone, myself Sriyash, and today we would be seeing switch-based security. So in this video, we would be covering the concepts of VLAN, Inter-VLAN, port security, and spanning tree protocol. So let's get started. So when we tell switch-based security, the first thing which comes to our mind is what is a switch. So basically, what we all know, switch is a device that is used to connect multiple computers. It's a non-intelligent device. It does not have any major routing thing to be done in it on a traditional switch. Its primary purpose is to connect multiple computers together. Okay, and when we have a group of computers connected together, working as wherein we can share the files and all those things together, they work as a local area network. They work as a LAN, we can tell. Okay, so what is a LAN? LAN is basically a group of computers which are grouped together and they can share the files and information among themselves. They're not connected to the outside world. They are just a group of computers working among themselves. And within the same concept comes the concept of virtual LAN, VLAN. Now, what is this VLAN? Now, suppose I have a university. Okay, let us take the example of say NIT University as well. Okay, so we have a university wherein we have around 1,000 computers that are connected using one switch. Now, ideally speaking, all the 1,000 computers should be able to communicate with each other because they're connected via the same switch, and that is ideally the case as well. If we look at this diagram without considering any concept of VLAN, because we see that we can see that all the computers, see this one, the IP address is 10.2, this is 10.3, this is 10.21, this is 10.22. So what we can see that all the computers should be able to connect with each other, should be able to communicate with each other just because they're on the same network and they're all connected by the same switch. So that is the concept of LAN. But when it has this concept of VLAN introduced, what we want is that we want some sort of a logical partitioning. Like we can say we want to divide or we want to separate the financial department from the HR department or from the education department. We want that within this one whole big network, within this one whole big house, we have separate rooms. Okay, and within each room we have some computers, and those computers can communicate within each other. We do not want anyone else to listen to their conversation, just like the way we do not want somebody from some other hostel room to listen to what we are discussing within our hostel room. So that is what comes when we say the word VLAN. So VLAN are basically a logical grouping of device in the same broadcast domain. This is the keyword. Within the same broadcast domain, we want to further separate the devices that are used to communicate. So VLANs are usually configured on switches by placing some interfaces into one broadcast domain and some interfaces into another. Now, what does this mean? This basically means that, see, when we have a switch can have hundreds of ports in it, depending on the type of switch. Of course, it can have multiple ports in it. Now, what we want is that some interfaces or some ports are a part of one VLAN, okay, and some other ports are a part of some other VLAN. Okay, so that is what our main focus is, and our the thing is, each VLAN should act as a subgroup of the switch ports in an Ethernet LAN. Without VLAN or broadcast sent. Okay, now look at this line again as I'm highlighting. Without VLAN, a broadcast sent from one host would reach all the devices on the network. Each device will receive and process broadcast frames, increasing the CPU overhead on each device and reducing the overall security of the network. Right? Because if you do not have a VLAN, if I do not have any partitioning, and if a person wants to tell something to even one person, everyone else is going to listen to that. That is the problem of VLAN. I want an information to be given only to those people who have taken MTech in cybersecurity. But if I do not have any separation and I pass on this message, maybe the entire university will be hearing it, which might not be desirable. It might not be very what we can say efficient. It might not be needed by others as well. So that is not something which you want. So that is when this logical partitioning comes into picture. Okay, so by having a VLAN, a broadcast from one host would reach only devices inside the same VLAN, since each VLAN is a separate broadcast domain. So when we are having a VLAN, we are basically having separate broadcast domains, and this is the key thing which we would be even seeing further now in our practical session. Okay, so host in one VLAN will not be aware of the communication that has taken place in some other VLAN. Okay, so this is what we meant by VLAN. So now how do we implement VLAN? How do we show the concept of VLAN? So for that, what we will see is that we can take a switch. Let's take a basic switch. Say I would take this switch, okay, and then let us take some few end devices. Okay, I'll take this end device 1, 2, and I will take this end device and yeah, this one as well. So what I've taken 4 end devices. Now let us have these 2 in some particular network. 110.2. I'll take the same example which I've taken in the slides. 10.3. Okay, 10.2, 10.3 belong to the same network. 192.168.10.4, and over here 192.168.10.5. Okay, not let's do this 10.23 and let's make this 10.21, just to have a big difference between two VLANs, so that we can have other systems as well placed in one VLAN. So what we want is that these two computers having the IP address 10.2 and 10.3 should be placed in one VLAN, and these two computers having the IP address 10.21 and 23 should be placed in some other VLAN. This is what our primary objective is going to be now. Now, how do I do this? So first, let me do one thing. Let me configure the IP addresses that I have given. So this will be 192.168.10.2. Okay, fair enough. This one would be 192.168.10.3. Okay, this one will be 10.21. Okay, 192.168.10.21, and now 192.168.10.22. Okay, let's make it 22. Okay, 22. Fair enough. Yeah. So now what I want, now without VLAN, suppose I do not have any concept of VLAN, and if I connect all these laptops or all these devices and devices together from a single switch, let us see what would be the scenario looking like. So I'll just take this one and I will connect it with this one port. I'll take this one, I'll connect it with this port 2. So this one I've connected with fast Ethernet 1, and this one, okay, let me do one thing. For easier implementation, let us do one thing. Let us connect this port. This IP address is 10.2. I would connect it with fast Ethernet 0/2. This would help the understanding be much more simpler. This one, this is 10.3. I'll connect it with port 03. Fair enough. 10.2 IP address connected with port 2. 10.3 IP address connected with port number FS0/3. Right? Now 10.21, I'll connect it with port 21, and 10.22, I'll connect it with port number 22. Just arrange these things properly so that they look a bit more realistic. So this is what our system currently looks like. These two are currently in the listening and learning stages. So yeah, we can see one link has become green. We'll just wait for a second, and now let's see, without any VLAN concept, what will happen if I just ping 192.168.10.3. From 10.2, we can see from 10.2, this is 10.2, I am pinging 10.3, I am able to ping. From 10.2, I will ping 10.21. Yes, I am able to do that as well. We can see that over here. And if I ping 10.22, I can ping that as well. So from one computer, we can ping all other computers because they are a part of the same network and they're connected by the same switch. They are all part of the same LAN, or even in this case, the same VLAN, as we do not have any other VLAN concept over here. So now what I will do is, I will logically try to separate them. I will put these two in one VLAN, and I will be putting these two devices in another VLAN. Okay, this is what my priority is going to be now. So this is going to be, say, VLAN 10, and this is going to be, say, 20. Okay, fair enough. So this is what I'm going to do. So how do I do that? I'll go to the switch, go to the CLI mode, I'll go to the enable mode, I'll go to the conf t. Okay, so first I would see show VLAN. If I give this command now, sorry, this won't work in the conf mode, this will work in the enable mode. So I'll give show VLAN. So if we see this thing right now, what we can see is that currently we have only one VLAN, and all the ports, port number 2, 3, 22, 21, all are connected in the same VLAN. We do not have anything else. Now we need to separate them. So how do I do that? So first I'll go to conf t, go to the configuration mode. Then what I will do, I will give interface range fast Ethernet 0/2 and 3, 2 and 3. Okay, I want in the one particular VLAN. So this we can see just comes the range. I'll give switch port mode access enter. Again I'll give switch port access. What do you want me to access? VLAN 10. Suppose I want these two to access VLAN 10. Now if you give this command, you see that VLAN 10 does not exist. So what it will do to create a VLAN 10. Okay. So now what I can do exit. Fair enough, simple. Similarly, what if I want to do for the other two ports as well? What I need to give? I'll give interface range fast Ethernet 0/2223. Okay. Switch port mode access switch port access VLAN 20. Okay, it will create the VLAN 20. That is what it will tell. Okay, I'll just press exit and enter. Now what I'll do, I will exit from conf mode. If I give the command show VLAN, now what we can see is that now we have two VLANs, okay? And port number 2 and 3 are placed in one VLAN, and port number 21 and 22 are placed on another VLAN. So now only 2 and 3 can communicate with each other, and only 21 and 22 can communicate with each other. They cannot communicate, 2 cannot communicate with 22. So this is what we mean by VLAN. And to verify the same, what we can do, we can go to this PC 10.2. From 10.2, I'll ping 10.21. Let's see if I can ping. It won't. All the links are green. You can see all the links are green, but still, can I ping? No, it won't let me ping. No matter how much I wait, it won't. If I try to ping 10.3, yes, I should be able to ping. Why? Because it is in the same VLAN, but I cannot ping any computer from this. Similarly, if I go to this particular 10.21 PC and I try to ping 192.168 or 10.22, yes, it will ping because it is in the same VLAN. It is in the VLAN 20. But if I ping from 10.21 to 10.3, will it ping? No, it won't. It will never ping because it is not in the same VLAN. So this is what we mean by logically partitioning a LAN or having a VLAN implemented. Okay. So I hope this was clear. Now moving on to the next slide. Yes. So now the obvious question that comes to our mind is, fine, we have this concept of LAN or we have this concept of VLAN with us, wherein we have separated the network into logical partitions. But what if I want to come, I am from say the finance department, there might be a situation wherein I want to communicate with someone from the education department as well. So how do I do that? There must should be some way. So meaning to say is that I belong to one VLAN. I am a part of one VLAN, and under some circumstances, I want to communicate with someone from the other VLAN. I want to communicate with the PC which belongs to the other VLAN. So how do I do that? So for that, we have this concept of inter-VLAN. Okay, inter-VLAN means two different VLANs want to communicate with each other. So how do they do it? So traditionally, there is a legacy method of doing it, and we also have a much more smarter method of doing it. So before going on to the smarter method, let us first understand the legacy method. How was it initially done within, or how can we even now do it using a traditional switch, using the same switch, whatever we have shown over here. Using this also we can do this, but how do we do that? So I'll just make a new blank system over here, and we will start with this part now. So and this concept of inter-VLAN demonstrated, what we can do is we can take a few end devices first. Let us take few laptops, the same thing which we had done. Okay, I take another laptop here, another laptop here. Okay, and what I would now do next is I would go to switch, take a basic switch. Okay, and now same thing, 192.168.10.2. okay, I'll go to here, desktop IP configuration 10.2. over here I'll make it 10.3. okay, I'll go to the IP configuration and I will make it 10.3. fair enough. Okay, now these two laptops also I want them to be part of a separate network only. Let's say, let us take the example of separate network. You can also have the same network, but then we have to introduce the concept of subnetting, which I will be avoiding for now, so that to keep things simpler. But yeah, the concept is more important. So let's have 192.168.20.2 over here. I'll go to this desktop 20.2, and over here I'll just have it as 20.3. okay, 20.3. So now what we would do is we would connect. First it connect to this one, 2 to 2 connected, 3 to 3 connected, 20.2 to I'll say 22, and 20.3 I can say connected to 23. Fair enough, right? So now we have two different networks in this, we can tell, and because they are two different networks, they cannot communicate with each other. So this is also another method of implementing VLAN, wherein we have computers connected to the same switch. Okay, physically they are all connected to the same switch, but they belong to some different networks, we can tell. And just because they belong to some different network, automatically they can never communicate with each other. So in this case also, if we try to communicate, we can see the same thing. So yeah, now all the systems are green. So if I just go over here and I go to command prompt and I ping 192.168.10.3, can I communicate? Yes, I should be able to communicate because they're on the same network and hence they're on the same VLAN. Over here, if I go and if I give ping 192.168.10.2, 20.3. From 20.2, yes, I can ping 20.3, no issues at all. But if from 20.2 I want to ping 10.2, can I ping? No, I cannot ping. Why? Because it is on a different network. Okay, so this is what we mean. So yeah, the request will time, it will never communicate. So now what I want is that these two PCs or these two computers which are on one VLAN, okay, should be somehow able to communicate with these two computers. This is what my current requirement is. How do I do that? It's the question. So how do I do that? Now one method, or the legacy method, what we were saying is that when we have a separate like network, or we have two VLANs, one method is to have a separate gateway for each VLAN. That is, for each VLAN we will have one gateway using which it will be connected by some external device, say a router, that will route the packets. Okay, so if we have 5 VLANs, we need to have 5 gateways. If we have 10 VLANs, we need to have 10 gateways. Okay, and what is the thing to remember is that suppose this one is 10.2, this is 10.3, and these two are belonging to one VLAN. Okay, so this interface that would be connecting to the router, this interface, say it is Ethernet port 10, fast Ethernet 0.1. This one and these two interfaces, the device interfaces, they should all be on the same VLAN. If they are all on the same VLAN, this entire thing, including this first dotted line, which we can see, this entire thing would be on one network, and this would be another network, and then using a router we can do the communication. Yes, this process is definitely going to be a bit slow because of the presence of a router, and we know that when you have a router, it's an intelligent device, it will have its routing table, it will have its own set of mechanism to learn and all those things. So yeah, it will be slower, and for this you need to have a lot of manual configuration done, and we need like the number of VLANs we have, we need to have that many number of interfaces. Okay, the gateway addresses and interface connecting the end devices of a VLAN need to be in one VLAN, and when we forward traffic from one VLAN to other, we should have a gateway interface. In this example, it was taken to be a router. Okay, so now if I just see over here, I go to my switch. For now, I go to my switch and go to enable mode. I just click show VLAN. So what do we see over here? As of now, there is we can see there is only one VLAN, and they are not able to communicate because they are on different networks. So now what do I need to do? I need some method for these to communicate with each other. So how do I do that? So the easiest method, or the traditional method, is take a router, put it over here. Okay, and then we will have this connection done. Okay, we can say connect this fast Ethernet 0/1 to, I will connect it with gigabit Ethernet 0/1, and I can connect this fast Ethernet 21 to 20 gigabit Ethernet 0/1. So using this, what we are going to do is we have connected these 2 points to 2 different points of a router, to 2 interfaces of a router. Okay, as we can see over here. Okay, so we will just write that over here, fast Ethernet 0/1 of which connected DID 0/0/0 of router. Okay, and over here as well, fast Ethernet 0/20 of switch is connected to GIG 0/0/1. I think this is not 20, this is 21. Let us verify that one. If we just hover over this, yeah, you can see port number. Okay, these two are down. Just do one thing, I need to delete this, I think. Yeah, sorry. Yes, I'll connect this one from port number 21 to 1, just to avoid any confusion. So this is what we have done till now. Okay, so basically we have taken over port of over here FA 0/1, which is connected to port FA, which will be within this particular VLAN. Let us take this example as VLAN 1, and we can have this one as fair enough. Okay, so what we want now, we want these two computers to be able to communicate with this. How do we do that? So we need to go to this router. I'll go to this VLAN mode. I'll enter no, I do not want anything else. Enter on T. Okay, so first thing that I need to do is I need to interface gigabit Ethernet 0/0/0. Okay, and now what I need to do, I need to add this IP address. Okay, IP address of these two particular VLAN, because we know that we should all be on the same network to be able to communicate. Okay, so how do I do that? I'll do IP address 192.168.10.1 space 255.255.255.0. Okay, I gave this IP address, I'll just exit. Okay, and now for the other interface, before exiting, I shouldn't have exit. I need to go there again so that I can give this no shut command, no shut. Okay, now I can exit. Now what I need to do, I need to interface with Gigabit Ethernet 0/0/1. I need to add the IP address 192.168.20.1 space 255.255.255.0. After I give no shut command, exit. Okay, exit. So now what I did, I just mentioned the IP addresses that I gave here. I gave 192.168.10.1. Okay, and the IP address that I gave here 192.168.10.20.1. These are the IP addresses that I gave here. Now what I want is that whenever this particular any computer from this VLAN needs to communicate with any particular computer from this second VLAN, it should pass through this 10.1 default gateway router. So this will route the packets appropriately. So what I'll do, I'll just copy this IP address 10.1 and I'll go over here and in IP configuration, I'll give this as default gateway for this one, and for this as well, I'll give it as default gateway. 20.1 copied and give it as the default gateway for this 20.1, and I'll give it as the default gateway for this as well. Okay, fair enough. So now ideally whatever traffic should be coming from here should be passing properly to this one. So and we can also see that this particular port and this all are on one network, like these two laptops and this particular the first port, the first dotted line, we can see these belong to the first network, and these the second dotted line and these two computers belong to the second network. And ideally they were not able to communicate with each other. We have seen that. But now if I just try to ping, let us see, if I try to ping 10.3 from 10.2, will it be able to communicate? Yes, it should be able to communicate because it is in the same VLAN. But if I ping 20.2, initially it will not be able to because it will be resolving the address and those things. But yes, soon it should be able to. Yes, now we can see the reply. So now we can communicate from 10.2 to 20.2. Similarly, if I want from 10.2 to 20.3, will it be able to communicate? After one or two failures, definitely it should be able to communicate because they are going through this router, through this intermediate device. We can tell. See, success. Now if I bring it already success because the address and protocols would have been resolved. So this is what we mean by the legacy method of having this concept of inter-VLAN. Okay. So here as well, if you want from 20.2, if I want, I can simply ping 10.2 and it will easily be able to communicate. So this was the concept of inter-VLAN using the legacy method, using the traditional method wherein we need to have a router in between to route the traffic appropriately. Okay, and this router would be the gateway interface, we can tell. Okay, now what is the second method or the more modern method? Now they saw that okay, this thing is not something which is very like rare or very peculiar. This requirement of having inter-LAN communication or inter-VLAN communication was something which was very obvious to happen in any organization. So instead of having another third or another secondary or another external device, they started making multi-layer switches. Okay, they started having multi-layer switches, and in this concept of multi-layer switch, the biggest advantage is that we do not need to have a separate router. The switch itself can do this routing thing. Okay, so here in this one we use a multi-layer switch to forward traffic from one VLAN to another. We should have a gateway interface. This is what our primary requirement is. To forward traffic from one VLAN to another, we should have a gateway interface. In the previous method, this gateway interface, this role was taken up by a secondary router, we can tell. But in this modern method, we can use a multi-layer switch which will work as the gateway interface, and hence we should be able to communicate from one VLAN to another. So to get this gateway interface in a multi-layer switch, we use a switch virtual interface facility in this MLS. And using this SVI, each VLAN can have its own gateway interface. Okay, I have 10 computers in this room, and all those 10 computers, if they have to communicate with some other 10 computers of some other room, I have a door. So if anyone wants to communicate, you have a door, you go outside through that door, you communicate and you come back in. So this is what the role of the SVI part of this MLS is. Okay, so in this architecture, we need not apply a separate physical gateway like router for enabling our inter-VLAN communication. Okay, so to demonstrate this, but I can just take the same example. What we would do is I would delete this router. I do not need a router. I will just delete these things as well. I do not need any of these things. Okay, this is what the original diagram was before we had a router, and now the difference that would come is instead of this switch, what I would do, I would go to switch. I would take a multi-layer switch. I think this one is a multi-layer switch. Yeah, this is a multi-layer switch, and this is what we want. Okay, so now let's go for the wiring. Pass Ethernet 0 to, okay, 10.2. I'll connect it with 0/2. 10.3. I'll connect it with 0/3. Fair enough. 20.2. I'll connect it with 22, and 20.3 I will connect it with 23. Clear enough? Fair enough. Nothing confusing over here. Another thing that we can remove from here is this default gateway. We do not need this anymore as of now. We can just, okay, let us do that in the later part. It's not needed as of now. So over here we can see that it is now learning and listening and learning. That is, this switch is trying to learn the IP addresses and all the other properties of these end devices, and we can configure this switch as per our requirement. And this is what we are going to do. So what do I need to do? Same thing that I did over here. We can see the same interface is coming just like in the case of router. I go to conf, okay, and what I would do over here is first I would interface fast Ethernet. What are the ports? 0/1 to 3. Okay, 0/1 to 3 I would go. Okay, something. Okay. Sorry. Fast Ethernet. Yeah, fast Ethernet. What do we want? Range. Interface. Range. Fast Ethernet 0/1 to 3. Okay, so these three devices 10.2, 10.3, and which are connected to port number 0/2, 0/3, and I'm also making port number 0/1. All these three ports I'm putting it into one VLAN. So what would I need to do? I will give switch port. No need to give that. I can just dial IP. I think what we can do, no need to do this one also. We can have even a better method, I think. Okay, let's see. What we can do, we can give IP. We need to get that. Okay, interface. Switch port, mode, access, switch port, access, VLAN 10. Okay, I'll put this into one VLAN. All these three ports, port number 0/1, 0/2, 0/3 on one VLAN. Okay, remember that, and we'll exit it for now. Okay, similarly, what I need to do, I'll go to interface, range, fast Ethernet 0/20 to 23. Okay, these three ports, 20, 21, 22, 23, these four ports. Okay, let's take four ports. What we would do, we would try to put them onto second VLAN. So what I would do, switch port, mode, access, switch port, access, VLAN 20. Okay, exit. So now we know that these ports are on a particular thing, and now we also know that these particular interfaces that we had given, that one is also on, like, I'll just give the command show VLAN to remove any ambiguity. Show VLAN. Yeah. So here we can see very clearly that now we have two VLANs. Port number 1, 2, and 3 are on one VLAN, and 20, 21, 22, 23 are on second VLAN. Okay. So now what I would do, I would go to interface. What I will do, config. I'll enter interface fast Ethernet 0/1. This particular port in the first VLAN, I'll enter that fast Ethernet 0/1. Or wait, I can then I'll just do interface VLAN. Okay. 10. I'll go to interface VLAN 10. I want VLAN 10, I'll go to VLAN 10. And now what I will do, I will give the IP address of this particular VLAN 192.168.10.1 space 255.255.255.0. Enter, no shut, exit. Okay, done. Now I need to again go to the VLAN 20 interface, VLAN 20 address 192.168.10.1 what was that? 10.1 I had given. Now what I will give? I will give 20.1 over here. 55.55.55.0. This is what I will give. 10.1, 20.1. Okay. Now shut. That's it. Okay. Now to enable this IP routing, what I need to give? IP exit IP routing. Okay, it's not working over there. Let's make it on IP routing. So using this command, the IP routing is now enabled. Now if I give exit and I give show IP route, yes, now what we can see is that this port 10.0/24, this network is for VLAN 10 and this 20.0 network is for VLAN 20. So now we have two different networks for two different VLANs, and now if we want to communicate within two different VLANs, let's see if we can do. So from 10.2, the first thing that I would do is I have to communicate with 10.3. Am I able to communicate? Yes, I am very well able to communicate. Am I able to communicate with 20.3? Let's see if it learns the address of it and if it communicates. Okay. If it doesn't communicate, we have to give the default gateway router address because we had not given that. So it might cause some issue. So let's see if it communicates, or else we will give that. Okay, it's not. No issues. Okay, so what we need to give? We need to tell this, okay, that okay, you have a default gateway router address as well. This is 192.168.10.1. And over here also this is 10.1. And over here it's I think 20.1 and that's same thing. So now if we try to communicate, let's see if it does communicate. Okay, yeah, see now it is able to communicate. From 10.2 it is able to communicate to 20.3. From 10.2 it is able to communicate with 20.2 as well. You can see that. Earlier it was not able to, but now yes, using this multi-layer switch we can able to communicate. So here we do not need to have a separate router. Using the same switch only we can establish inter-VLAN communication, and this is the beauty of this modern technology. If we want over here as well, from 20.3 let's try to ping 10.2. 10.2 can we ping? Yes, we are able to ping. So this is how inter-VLAN works using a multi-layer switch. Okay, so this was for that part. Now coming to the next thing is about port security. Now we understood the concept of LAN, we understood the concept of VLAN. Now the next thing that is of prevalent importance in this concept of switch security is specific port security. Now what does this thing mean? We know that a switch can have multiple ports. Now what we want is that we want a method using which we want a particular port. We want a particular port to to recognize traffic from a particular set of allowed devices only, so that in case some unauthorized person or some unauthorized device is trying to enter into the system, is trying to inject traffic into our system, the port should either shut down or it should go into a protect mode where it will just ignore the traffic. That is what we mean by port security. So over here in this diagram, if you see, we have a switch. Okay, one of the port is connected to a particular device, say a laptop or anything. Now for the second port, what we want is that the second port should recognize a traffic that is coming only from these two devices, whose MAC address we would either statically enter into the switch, or we would have some method using which it will learn the MAC address of these two devices on runtime, and it should allow traffic only and only coming from the recognized devices. This particular port should allow traffic coming only from these two recognized devices. If any other outsider comes, okay, if any other outside computer comes, it will either shut down or it will just ignore that traffic. That is what we mean by port security. Port security provides the ability to limit what addresses will be allowed to send traffic on individual switch ports within the switched network. Port security helps secure the network by preventing unknown devices from forwarding the packets. Take this for example, that we have a university and we want that only those laptops which are authorized by the university should be able to connect to the university LAN. So we can just enter the list of MAC addresses for those devices, and any other device that is entering the system without prior approval will not be able to communicate. The traffic from that particular device will be simply blocked or ignored. Okay, and this is enabled on a per port basis. Okay, so for each individual port we need to configure this. So hence the name comes port security. How to demonstrate port based security? So for that, what we can do is we can take some switch. First, I'll take the switch, and I'll take some end devices. I'll take, say, 4 laptops. Okay. Now what we have to do is, as we said, that port-based security works on individual ports. So for demonstration, we will consider 2 ports. One port, say fast Ethernet 0/2. I will fix it with this laptop. Okay, 192.168.10.2. Port FA0/2. I'll fix it with this laptop having IP address 10.2. And the other, okay, let's choose this. Choose port 2. And for the port 1, for the port FA01, what I want is that it should dynamically learn the MAC addresses of maximum 2 devices. And these 2 devices, these 2 end devices are the recognized devices, we can say. So what happens practically is that suppose there is an organization, and for they have multiple ports, and for each port they can configure the port security where they will be having a list of devices which are called recognized devices. And if the traffic is coming only from those list of devices, only then will be the traffic processed. If the traffic is coming from any other unrecognized device, then the traffic will not be processed. The port would either shut down, or it would just go into an ignoring state, the protect state, or it would just ignore and keep a track of the logs. Okay, these are the 3 options available with us. So now what we can do is, let us first have all the IP addresses assigned so that it doesn't create any confusion. 10.3. I'll go over here, I'll give the IP address 10.3. I'll go over here, give that 10.4. I'll go over here, sorry. I'll go over here, I'll give the IP address 10.5. Okay. So now for demonstration, we would consider that we want the port FA0/1 to recognize only these 2 devices. And how can we make the port recognize? How does a port recognize a particular device? It is based on the MAC address of the NIC card of the device. Okay, so if you see this laptop over here, if you go to this configuration, we can see this fast Ethernet 0, this NIC card has this MAC address, and this MAC address we want the switch to learn. Now we can either manually give this MAC address, or what we can do is we can give the sticky command so that and you can have a maximum number of devices set, so it will automatically learn this address. This address will stick to its memory, we can tell. Okay, so this is what our primary objective is. Okay, so I will copy this MAC address, for example, and now what we want is that we want this switch to learn this MAC addresses. So how do I do that? So first I need to configure the switch. I'll go to enable mode, I'll go to mode, I'll just expand this so that it becomes easier for everyone to view. Yes, so I'll go to interface, fast Ethernet 0/1. This is the port on which I want the security. So first thing, I need to ensure that the port is not in dynamic mode, it's in access mode. Then what I need to do, I need to enable port security. Port security is enabled. And now if I see the options, how many options are there? We have 4 options. So the first option that we would give is maximum how many IP addresses, MAC addresses we want, sorry. So I'll give maximum 2 MAC addresses I want. These 2 devices are recognized devices. Okay. And what would be the MAC addresses for them? If I give this MAC address option, I can either give it manually. If I have to give it manually, I can just paste it. This is one MAC address. Or if I want, I can also give the sticky command so that it will learn the MAC address on the fly. Okay, I give the sticky command for the second device MAC address. We did not give it manually. We did this, and then we can just click exit and exit. So if I now give the show MAC table address table, we do not have any entries in that. Now why? Because we have not done anything. If you have not done anything, how will it learn the MAC address at all? Okay, and thing is, we can also give show port security on interface fast Ethernet 0/1. If we give this command, we can see that his port security is now enabled. Okay, port security is enabled. The violation mode is shut down. That means if an unauthorized device is trying to connect, it will just shut down the port. Okay, and maximum MAC addresses that it can learn is 2 MAC addresses it will learn. And how many MAC addresses it has already learned? It has learned 1. Why? Because they have hard-coded that MAC address. And it will learn maximum 1 more MAC address. Okay. So configured MAC address we can see as 1, and sticky MAC address we are not yet it has not yet dynamically learned anything on the fly. So this is our setup done. And now what we can do is we can happily go and try to connect. I'll connect this laptop 1, fast Ethernet 1. Okay. And now we will just wait, or if you want to speed up the process, we can go to time 3 and we can give be like it will speed up the listening and learning process, and we can directly get this green line. Once we get this green line, we can try to ping, and we will see if this laptop 10.3 is able to ping 10.1. Okay, so now it is done. Now I go to 10.3 and go to desktop command. Okay, sorry, 10.2, I clicked by mistake. It is 10.2, not 10.1, sorry. It is able to ping. So we are able to ping this particular computer. This is on another port, and we are able to ping this computer without any issues. And if I see over here, the last command, show. Okay, exit the config now. Show port security interface. It is still saying that okay, one MAC address is configured, and this is the last source VLAN address. Fine, no issues have been encountered till now. Everything is fine. Security violation is 0. Now what I will do, I will delete this now. And what I will do, the tricky thing now, I will connect this computer to the same port 0/1. Okay, and now as we had enabled the spanning tree port first, we immediately bypass the listening and learning stages. Okay, and now if I give a ping command from here, let's see if I'm able to reach 192.168.10.2. Should I be able to reach? Yes, I should be able to reach. Why? Because it should learn 2 MAC addresses. One we have given, the second one it learned. Okay, let's see if it is actually learned. We can see now the configured MAC address is 1, which was as like it was expected, and now we can see the sticky MAC address is also 1. That is, it has learned this new MAC address. Okay, that is what we were trying to show. This is the meaning of port security. Okay, and so we are able to communicate. If we further give a new, suppose a third device comes, okay, then let's see what happens. Okay, now suppose I am connecting this outside laptop to this network, then we can see this is red. Why? Because it is in the shutdown state. We can see port status is secure shutdown. Because of the security violation that has occurred, the port has been shut down. So this prevents any unauthorized device, any outsider device, any outsider MAC address to inject traffic into our system or to get traffic from our system. So this is the beauty of having port security enabled. Now we can see that okay, this has completely shut down. Now what will happen is, even if I give a valid reconnect, like we can say the genuine computer to this, still the port is in shutdown state. Why? Because the security violation has already happened. So what do I need to do that? I need to again go to the conf into interface with fast internet 0/1. I give shutdown and then shutdown. Okay, now it will become green, and now if I try to ping, okay, it will work. 10.2 will ping. So this was one way of implementing this port security, in which the moment a violation occurs, the port is completely shut down. Another thing which we can manipulate, or which we can do, is we can have this config mode switch port security, and we can have violation, and if you see the option, this was the default shutdown. Okay, now we want protect. Now what will happen in protect? It will just ignore the traffic. Whatever traffic is coming from an unauthorized device will be just ignored, but it will not log the information. It will just ignore. And if you want to log the informations also, then we can use the restrict command. So just for demonstration, I'll just use the restrict command and click on enter. Now exit. Now if I give this option, we can see that okay, it is enabled, and MAC addresses total it has learned 2. One was configured manually, one it learned dynamically, and now let's try to ping. Let's see if anything happens. We'll try to ping. It is able to ping because it is a recognized device. Okay, these two laptops are recognized devices, so no issues at all. Okay, I'll just give you a recognized. Sorry for this. This is the text box, and these are recognized devices. Okay, fair enough. Now what I will do, I will remove this line and I'll connect back the 10.3 to switch 0. Okay, now I will try to ping from 10.3 to 10.2. Let's see what happens. We are able to communicate. Why? Because it is a recognized device. If we see the switch also, okay, absolutely no issues. Security violation count is 0. No issues. It is still enabled. The violation mode is restrict. Now we will try to see the outline. What we will do is we will connect this outside the laptop to this switch. till it is green. Earlier in the shutdown state, it was turning to red. But here the link is green means it is active. But will it allow the traffic? Let's see that. Let's see that. Ping 192.168.10.1. Sorry, not 10.1, 10.2. Sorry. It won't. Why? Because it will just ignore the traffic and it will keep a log that is this outsider MAC address and try to intrude the system and try to get into the system without proper authorization. It won't communicate. No matter how much we wait, it will never communicate. And if we verify the same over here as well, we can see that 6 security, because for everything it will log a security violation. Okay, so this is a violation mode restrict. Okay, so this is what we can see that, okay, this is the MAC source address which has caused this violation, and we can see that if I just better to communicate from this 10.2 to 10.5, even then I won't be able to communicate. 2.168.10.5. It won't communicate no matter whatever we do, because the port is in secure mode now. It is in restricted mode, wherein it will just ignore the traffic. And the moment what we do, we will remove this line, and a recognized devices tries to connect. We can immediately go ahead and carry on with the normal ping commands to ensure. See, we can work. Earlier, what we used to do, when the default violation mode was shut down, we had to manually go and again restart the particular port, but here it will automatically work, no issues. So this was a brief idea on the port security, wherein specific ports are configured to accept and to recognize or to process traffic from recognized or from authorized devices only. Okay, I hope this was clear enough. Now, moving on to the next part is the spanning tree protocol. Now, what do we mean by the spanning tree protocol? Very simple thing to understand. Like, suppose there is a situation wherein we have multiple switches, okay, and the switches are connected with each other. So there might be a possibility that when there is a broadcast message going on, switch 1 will send a message to switch 2, switch 2 will send a message to switch 3, and if the switch 3 is connected to switch 1, then there might be a loop, okay, that will form. Okay, we can tell something like an echo that happens. So to avoid these continuous loops, okay, when we have multiple link, if you see this line, when we have multiple link between the switches, there is a high probability that multiple links can be formed between the switches. Like, it's an obvious thing, like if you have multiple if you have established multiple switches and you have given multiple links, then it is a high probability that yes, there can be multiple loops. This will be loops, ignore the spelling mistake. This will be multiple loops can be formed between the switches. Spanning tree protocol stops these loops when we have multiple links between the switches, and it is a standard protocol that runs on every switch by default. Okay, it will analyze the links, and if there are any redundant links, it will put any one link into forwarding mode and the others into blocking states. Meaning to say is that suppose I want to reach a particular destination from point A, I want to go to particular point B, and when I'm in a hurry and I see two roads before me, I get confused which one to go for. So if I have in those cases, I am just able to see only one road, that confusion will be avoided. I'll just go ahead with that. So this is what the spanning tree protocol does. It does some calculation, which I won't go into much detail of. It does some calculation and it finds the best path to reach the main node, the forwarding node. Okay, whenever we have multiple switches connected, I'll just demonstrate that over here. Whenever we have multiple switches connected, okay, in a loop, there might be a possibility of a loop. So what this spanning tree protocol does is that it identifies one particular switch. Okay, it will identify one switch as the forwarding switch. We can tell that will be the main switch. Okay, and all the other switches would refer to that particular switch. They would try to reach that particular switch in the shortest path possible. Okay, and hence they would be having the forwarding ports. That is, suppose we have 10 switches connected. Okay, so one switch would be the main central switch, we can tell, and all the remaining 9 switches will have they will have only one particular port to reach to that particular main switch. So for one root switch, there would be 9 root ports from the 9 non-root switches, we can tell. Okay, so that is what has been mentioned over here. Okay, so first we have to select the root bridge. Okay, which would be the root switch, we can tell, or the root bridge. That would be like the central switch or the central bridge. And then for all the non-root bridges, okay, each and every single non-root bridge has to select one and only one single root port. Okay, so based on some mathematical calculations, of course, it will select. Basically, to keep things simple, it will go see the lowest cost. Okay, it will see calculate the lowest cost. It will see the priority, and it will see how what is the internet speed and how many hops I need to cross. And based on some parameters, it will see which is the shortest way, which is the easiest way to reach the root bridge. And for every non-root bridge, there has to be one and only one root port using which it will try to reach the root bridge. If this main root port is down, or this main path is down, then will it think of taking the alternate path. Otherwise, it will never consider the alternating path. So this is what we mean by spanning tree protocol. So to have a demonstration for that, what we can do is a very simple thing. We can just take few switches. I will take this switch 1, 2, and 3. 3 switches I took. Now what I'll do, I'll try to connect them using cross cable. Pass Ethernet 0/1 connected to 0/1. Okay, fair enough. Now 0/2 connected to 0/2. Okay, fair enough. Till now, has there been any loop formation? No. This switch can communicate with this switch and only with one route. One way is there. There is no secondary option for this switch to communicate. For switch 1 to get to switch 0, there is no other option. Only one way is there. Similarly, for switch 2 to reach switch 1, there is only one way. To reach switch 0, also there is only one way. There is no secondary option for this switch 2 to reach to switch 0. Okay, but if I connect another, we can say fast Ethernet 3 to 3, suppose I connect. So in this case, for switch 1 to reach switch 0, there would be two paths. One would be this particular path over here. The second option would be this particular path plus this particular path. Fair enough, right? So this is what we mean by spanning tree protocol, because now what it will do is it will automatically be running in the background. It is enabled by default, and in these circumstances, it will disable one link. Okay, so here we can see this part is green, this part is enabled, but this part is orange. It is not enabled. Okay, why? Because if this particular port is enabled, if this light blinks green, that means a loop will be formed. Hence, to prevent the formation of a loop, this particular port has been stopped, has been blocked. So here now, if the switch 1 will try to reach to switch 0, which path it will take? It is bound to take this path. Can it take this other path? No. Why? Because this port is orange. Similarly, for switch 2, if it has to reach to switch 0, can it take this path? No, it cannot take. Why? Because this path is orange. So it has to go with this path. Similarly, for switch 0, if it wants to communicate with switch 1, it will go with this path. And if it has to communicate with switch 2, it has to go with this path, not this one. Okay, and how do we verify that? Which is the main switch, the root switch we can tell. So what we can do for that, very simple. We can just go and I don't think we show spanning tree. Yeah, show spanning tree. This command is there. So now this was in the switch 0. So what will it say? That okay, show spanning tree command given. This is the priority. This is the default priority. Based on this, and some calculations are done. Okay. So this is the port 1. Hello time. Now how will the switches advertise itself? That okay, this is my advertisement, and this is how you have to these are my details. So they keep sending hello messages in which they interchange their values, that their corresponding priority values, their MAC addresses, and other details. Every 2 seconds they keep on exchanging these messages. So is this the root bridge? Is switch 0 the root bridge? No. Why? Because we can see it has one root port and one designated port, and it is not mentioned anywhere that it is the root bridge. So definitely switch 0 is not the root bridge. Now why is it not the root bridge? Let's try to identify that. Here the priority value is 3276, which is the default priority value, and this is the MAC address. Let's copy this MAC address. Okay, this is just for easier understanding. Okay, now I'll go to switch 0 is not there. I'll go to switch 1. Okay, I'll go to switch 1. So yeah, enable mode, show spanning tree. If I see this, okay, what do I see over here? This bridge is the root, means this is the root bridge. Okay, so this switch 1 is the root bridge. So this switch 0 can reach switch 1 in the easiest way. Switch 2 can reach switch 1 in the easiest way. And there is no other way by which switch 0 can reach switch 1 or switch 2 can reach switch 1. There is absolutely no other way. There is only one way. Okay, and if we see, both the ports are designated ports over here. Okay, and why is this the root bridge? Because if we see this address, we can see that for this, if the priority value is same, the lowest MAC address, the device which will be having the lowest MAC address, that would be taken up as the root bridge. Okay, So this is the root address, sorry. So yeah, we can just copy this. This is not a MAC address though. The MAC address will be over here. Physical fast Ethernet. Okay, so let's ignore the MAC address for now. I don't think it's necessary even for this. You can ignore this part. It's not necessary. What is actually necessary is this CLI. If you see this portion over here, we can see which is the root. So we can now understand that this is the root bridge, and here there are two designated ports, port 1 and port 2. If you see this one, switch to, we go to enable mode and we can see that yes, one bit for each non-root bridge there has to be one root port, and the other would be the alternate one which is in the block status. So this is the one root port which is in the forward mode, and the other one, because if this one would be allowed, it would like create a loop, so it has been blocked. Okay, so this is what we can see over here. But now if suppose to reach this switch one, for some reason this particular link is broken, then what happens? Then after some second we will see that this portion has turned green, because there is no other, this switch 2 will definitely try to reach switch 1. So how will it do that? So for that it will automatically, this portion will turn green. So we can just verify that within a few seconds, I think. Show spanning tree. I think, yeah, this is now, it is in learning stage. We can see, we have to wait a bit more. See, now it is in forwarding stage. See, it has become green. Why it became green? Because it has to reach the root bridge. Somehow it has to communicate. Each non-root bridge will try to reach the root bridge via some root port, via some path. Okay, if the root path is not available, then it will go to the alternate path. So here we can see the alternate path that was there, that has become the actual root port, and this is now the forwarding mode. And now this switch 2 can communicate with switch 1. Okay, and this switch 1 will be still the root bridge. Even if you verify that. Okay, now is it in this one? Just exit. And show spanning tree. We can see that yes, this is the root bridge, and this interface is in forwarding. This particular interface is in forwarding. So absolutely no issues. If you want, we can also experiment with another switch over here. We can just have another switch over here, and if you want to connect, we can connect. Absolutely no issues. This is the root bridge. Okay, so this switch has to communicate with this switch, so it can easily communicate with this particular path. It need not take any other path. So even then, we can see this is still in the listening stage. We'll wait for some time, and now what we can see is that okay, this particular, we're not sure now that if this will be written as the root bridge. So let's wait for the learning stage to get over, and then let's verify if we can see if this is the root bridge now or not. So now what we can see that no, this is not the root bridge anymore. Okay, this is not the root bridge. It one port is now in the like both the ports are forwarding, and one is the root port. This is the root port. FA0/4 is the root port, and I think root port is the port using which it will reach the root bridge. So now this seems to be the root bridge. Let's verify that. If we go over here, we go to enable on, and okay, I'll give show spanning tree. Now we can see that this new device is the root bridge. Okay, this is what we meant by spanning tree protocol, because now it will verify, it will keep verifying which is the root bridge, and it will try to ensure that all the non-root bridges have only one unique way of reaching the root bridge. So this bridge is the root bridge, and we can see that over here, and this switch can reach here by only one way. So this is what we meant by spanning tree protocol, and this is what we specifically meant by port security. So till now, whatever we have discussed, if we just go through that in a very quick way. We first understood the concept of VLAN. We saw what LAN was and what was the concept of VLAN. And here we can see that even if these devices 10.2, 10.3, they are belonging to the same, this 10.21, all these belong to, all these 4 laptops belong to the same network, yet they cannot communicate with each other. Why? Because they have been logically separated into different VLANs. So this was the concept of VLAN. Next came the concept of inter-VLAN routing using the legacy method, wherein we had different VLANs and we want the devices to communicate within each other. Like this device from this VLAN should be able to communicate with the device from this VLAN. And for this, the legacy method says use, because see, you need to have a gateway interface between two networks. So the gateway interface was a router in this case, and the default gateway interface was put as this gateway address over here, and then only like the traffic from this laptop was able to reach this switch. From this switch it went through this router, and then again from this router it came back to the switch, and then again it reach to this particular device, we can tell. So this one was the legacy method, wherein the packets have to take a larger, a longer path. We can tell it has to go through an intermediate router as well to reach the device into some other VLAN. So this was the legacy method. And using a mod, nowadays we have this multi-layer switch, wherein we can just, instead of having the router, the switch itself can work as a router, we can tell. So we can have this gateway interface over here configured in this switch, and then using that only, these two devices from these two different LANs can communicate with each other. Then we saw port security, wherein we were able to ensure that only the recognized devices, only the authorized devices were able to communicate using a particular port in the switch. And if any other unauthorized device was trying to connect, the port either got shut down or it just ignored the traffic. That is where we learned in port security. And over here in spanning tree protocol, what we just saw over here is that one and only one particular switch is the root bridge, and all other switches are the non-root bridges who try to reach the root switch without forming any loop, and they will have only and only one root port to somehow get to the particular switch. That is, they will follow only one, from their exit interface, they would have only one. Even if there are two exit interfaces, for them to reach to the root switch, they would only go for one of them, okay? So that no loop is created. And this prevents the creation of any internal loops, we can tell. So this is what we meant by spanning tree protocol, and this completes my video presentation for the switch-based security, and I hope that it was useful and informative. So thank you very much for your time. Thank you.